All right, so we're at part 3 on 4.5. This was a long section for us, but it's an important one. Trigonometry is a very important topic for us. The last missing piece, though, is to be able to find angles in right triangles. We know how to use SOHCAHTOA. We know how to use SOHCAHTOA to find a missing side. That's what we did in part 2. The last step is, let's say we want to find an angle in a triangle. And to do that, we're going to need the inverses. So let's start with that. So first of all, let's just remember what inverse means in math. An inverse works a question backwards. So things like multiplying and dividing by inverse are inverses. If 3 times 6 is 18, then 18 divided by 6 is 3. The question works forwards and backwards if you multiply or divide. Another real common example is adding and subtracting. If 5 plus 7 is 12, then 12 minus 7 is 5. The questions work forwards and backwards. So our inverse trig functions are going to do that. We'll get to that in a minute, but first of all, let me show you what the inverses are. You guys may have noticed on the calculators, as you were doing your work from yesterday, our 3 buttons for sine, cosine, and tangent, SIN, COS, and TAN. In green above them, when you hit the shift button first, or that second button first, you have each trig function with a little -1 on it. Sine -1. Well, that little -1, that's our math symbol for the word inverse. It looks like an exponent. It's not. It's not a -1 power. It actually means inverse sine. We also have inverse cosine, which would be COS with the little -1 after it. And of course, we have inverse tangent too. So if I take any of my 3 trig functions, sine, cosine, or tangent, which is SIN, COS, or TAN, and I put the little -1 after it, that means inverse of that trig function. Inverse sine, inverse cosine, or inverse tangent. So what looks like a -1 exponent is not an exponent. It's a math symbol, and it means the word inverse. All right, so here's how it works. If I told you x equaled sine 20, that's like the end of our question from yesterday. We already know what x equals. You just take a calculator and you type sine 20 and you get your answer. But let's say I move some things around. And this is what I would get. If you type it into a calculator, round it off, you get 0.342. So let's say I say sine 20 in a calculator, I get 0.342. Now let's switch the 2 numbers. And what I mean by switching the 2 numbers is like this. You take the 20, you move it over here. You take the 0.342, you move it over here. By doing that, it actually turns it into an inverse trig equation. So if sine of 20 degrees equals 3.42, which it does, then inverse sine of 3.42 equals 20. Remember, just like 3 times 4 equals 12, so 12 divided by 4 equals 3. Same thing here. Sine of 20 equals 0.342, so inverse sine of 0.342 equals 20. And I said you can try it if you want. If you happen to have your calculator with you, grab it and try it. You have to use the green second button to find the inverses. But if you grab a calculator and you type inverse sine of 0.342, you're going to get 20. It may not be exactly 20 because we rounded off, so it might be like 19.999 something or 20.0001 or something like that, but it's about 20. All right, so let's do this. First of all, to kind of highlight what we're doing here, this is not inverse trig. This is what you did yesterday. If I told you to solve this equation for x, tangent of 27 equals 8, I would just solve this by multiplying both sides by 8, like we did yesterday. I said, I'm looking at the x, I see it's divided by 8. I'm going to use a times 8 to cancel that 8 right there. I've isolated x. My answer is 8 times tangent of 27, which, let's see here. Let me pause and do that on a calculator. I'll come back. That's a little bit over 4. It's like 4.1. Okay, nothing new there. I just wanted to remind you of what we'd done yesterday. Let me take two numbers and switch them around, though. I'm going to give you the exact same question, but what I'm actually going to do is switch the x with the 27. So let's do this. Let's say I ask you to solve for x, and I say tangent of x equals 27 over 8. Like I said, I just copied and pasted the problem, and I switched the x and the 27. So see, now the solving part is completely different. I can't just multiply by 8 or divide by 8 or multiply by 27 or anything like that. If I want to isolate the x, I need to get it outside of the trig function. And the way we do that, remember what I showed you on the last slide? We're going to switch these two numbers, the x and the fraction. And by doing that, instead of a tangent, I now have an inverse tangent. So I turn my regular tangent into an inverse tangent, and then I switch the two numbers. So I have inverse tangent of 27 over 8 equals x. And see, now this is what I want to type into a calculator. I want to type inverse tangent of 27 over x. So I'm going to grab a calculator and do it. I actually did it when I was paused a second ago. It comes out to about 73.5 degrees. So that's the difference. What I want you guys to notice is when you use inverse. When you use inverse is when the variable is here inside the trig function. If it says sine of x or tangent of y or cosine of z, those are the times you're going to use inverse trig. It's also when you're finding an angle, which is what we're going to talk about next. So let's do that. The first thing I want you guys to recognize, when you use inverse trig, the answer is always going to be an angle, because it works the question backwards. In regular trig, you start with the angle. You do like tangent of 20 degrees, and you get a number. When you do inverse, it turns it back into an angle. So, yesterday, we used SOHCAHTOA to find missing sides of a triangle. Today, we're going to use it to find a missing angle. The difference is we're going to have to use inverse trig to do that. So before we get to the inverse trig part, let me start with something I want you to know, because there's a real easy way to do some of these questions. One thing we've noticed as we've been studying trig is if you have a right triangle, the two angles, not counting the right angle itself, always add up to 90. So if you already know one of the angles and you need to know the other one, don't do SOHCAHTOA, just subtract from 90. Definitely do this when you can. It's much easier than doing the trig. The trig would get you the answer, but it would take a ton of work. Why do a bunch of work when all you have to do is subtract from 90? And here's an example of that. So let's say in this question, I asked you guys to find measure of angle B. You actually could do it using SOHCAHTOA. You could label opposite, adjacent, hypotenuse. You could use inverse trig. It would take a lot of work. Instead, I'm just going to look at this picture. I'm going to say, well, I already know one of them. Angle A is 53.13 degrees. If I want to find angle B, I'm just going to subtract from 90. And you can even use a calculator. Grab a calculator, you do 90 minus 53.13 would be what, 36.87 degrees? I mean, that's your answer, 36.87. So it's really, really simple. If you already know one angle, don't do the trig. Don't do more work than you have to. Don't do SOHCAHTOA, do it the easy way. If you know one angle of a right triangle, subtract from 90, you got the other one. Now let's say we didn't know that 53 though. Like let's say I gave you this question and the 53.13 was not there, and I said find angle B. We could still do that because I gave you two sides. So what we could do is take the 8 and the 10. We could figure out which sides they are, opposite, adjacent, hypotenuse. Use that to choose a trig function, just like yesterday, sine, cosine, or tangent, and then we'll end up using inverse trig to find it. So let's do that next. In that situation I just described, you don't know either angle, but you know two sides of a triangle. You can use SOHCAHTOA to find either of the angles, actually. So we're going to set up the question just like we did yesterday. We're going to do opposite, adjacent, hypotenuse. We're going to use the two sides we know, to pick the right trig function, sine, cosine, or tangent. We're going to set up an equation, we're going to solve for x. The difference is, at the end of the question, because we're finding an angle, you have to use inverse. And that's it. That's the only difference. So let's find angle B in this picture. Angle B right here. And in fact, what I'm going to do, I'm going to put an x right there where angle B is and turn this into a solve for x question. Now see, this time I don't know what angle A is, so I can't just subtract from 90. It's not as easy. But I can still do it. So let's do this. Let's label our sides opposite, adjacent, and hypotenuse. The 9 is the hypotenuse. I can tell that because it's opposite from the right angle. Now, if I'm finding angle B, then angle B is the one I'm using in the question. That means opposite from B, and that would be this side over here, the blank side. Now, if the 9 is hypotenuse, if the blank side is opposite, then that means the 6 is adjacent. So the two sides that I want to use are the 9 and the 6. See, I don't know the opposite. I can't use opposite. And it works out exactly like it did yesterday. So I'm going to write it up here. Here's our SOHCAHTOA. The two sides that I circled are the hypotenuse and the adjacent. That's right here. That makes this a cosine question. Now, just like yesterday, it's the only one that works. I don't know opposite. So I can't use sine and I can't use tangent. Both of those need opposite. So only one works. You just got to find the one that works. In this case, the two sides I knew were the A and the H. So this has to be a cosine question. All right, let's finish the question. We decided it's cosine. After you decide it's cosine, remember, you always write the angle. Now, yesterday the angle was a number. It was like cosine of 20 degrees. Today, the angle is x. So I'm going to write cosine of x. Oops. Let's go back to our black pen. It's hard to see. I'm going to write cosine of x. Now, remember, cosine's a fraction. We're going to go back to SOHCAHTOA. Cosine equals adjacent 6 over hypotenuse 9. Now, all of a sudden, it looks like the question I did with you earlier today. I said, whenever the angle is the x, what you have to do is switch the x with the number, the whole thing, the 6 over 9, and turn it into an inverse question. So this becomes an inverse cosine instead of a regular cosine. We put the 6 over 9 here and the x over here, and that's what you type into your calculator. Inverse cosine of 6 over 9. So I'm going to pause one more time because I haven't done this on the calculator yet. And it comes out to about 48.2 degrees. So there's our answer, 48.2. You're doing the exact same work as yesterday. You're setting up a triangle, you're labeled opposite, adjacent, hypotenuse. You're using two sides to pick sine, cosine, or tangent. Set up an equation. The only difference is at the end. When you actually reach for the calculator, instead of having to solve for x and use a regular sine, cosine, or tangent, you're just reaching for your calculator and you're doing inverse sine, cosine, or tangent. And that's a good thing for you to remember. If you're finding a side of a triangle, it's a regular trig function. If you're finding an angle, it's an inverse, always. Now, before we go, one last little note for the homework today. Whenever you see the phrase solve a triangle, you're going to be asked in tonight's homework to solve a triangle. The word solve means find everything. It's not going to say find x, find y, find z, find this angle, find that angle. It's going to say solve the triangle, and that means you need to find everything. If both angles are blank, you need to find both of them. If one side is blank, find it. If two sides are blank, find both of them. You need to find every missing piece. Now remember what I told you about angles. If both angles are blank, use SOHCAHTOA to find the first one, but then don't do SOHCAHTOA again. Just once you find the first one, just subtract 90 to get the second one. So you guys know how to do this now. We already did it piece by piece. Solving a triangle is putting it all together and finding everything.